Hello and welcome to the next part in our PySpice introductory tutorial. Today we're going to be talking a little bit about how we can include external models and libraries into our PySpice Spice simulations. So we're going to be briefly looking at why we might want to do this, why do we want to use these external libraries and import them, and then we're going to go through a brief LTSpice example before we move on to showing how you can import external libraries into a PySpice netlist. So why do we want to have these separate device models and device libraries? Well, if we didn't, what you might find is that our models would get quite cumbersome. We'd have to define the models every time we want to use them. Our netlist could perhaps get a bit cumbersome and confusing. And there's a much simpler way, and that simpler way is to build up a library of devices and then just import them, and then we can use them from the library. This is how it's been, this is how it's commonly done in Spice software. And this is incredibly useful because we can just build up a library of our devices. In addition to this, manufacturers often produce Spice models and Spice libraries of the electronic devices that they are producing. So quite often, if you're looking for a particular device, if you just look it up on the internet, you can usually download its Spice model, and then you can import that library into your Spice simulation, and you can use that device. So it's very, very useful. These models in the libraries are generally a model that defines the component, for example, a diode, and then maybe a subcircuit that fits all together, and you can import this and just use it. And these .lib files can contain more than one type of model as well. So we're going to move over to LTSpice, and we're going to have a quick look at an example there. So here we are, we're on LTSpice, and you can see we've got a very basic circuit. So we've got a voltage source, which is connected to some two-terminal device, and then to a shunt resistor to ground. Now, in some ways, it is actually we have to produce a two-terminal device and then sort of circuit, visual circuit component, and then we link that to the imported model. So these are quite often known as like an X component. So it's like it's a component that's sort of been predefined. As you know, X is defined as a subcircuit. So basically, we've kind of produced this subcircuit, and we've defined the subcircuit as the imported circuit. In this case, we're using a diode, a 1N4148 diode. And as I say, I've created this two-terminal sort of representation of a thing within this sort of circuit GUI, which is being filled out by this diode. So if we open up our thing, you can see I've got this file's called dimport. But you can see I actually have my .lib file here, and if I open that up, you can see that these stars are comments. So that's a netlist comment, and you can see this is just a diode that I've downloaded off the internet, and we've got the subcircuit defined here, and then we've got the model which defines the diode itself. So that's saturation current, breakdown voltage, etc. So this is defining that diode in a .lib file, and we can import that by using the .include command. So we can include it, and then if we run it and we probe voltage, we can see that indeed it is behaving as the diode we want it to. So that's great. So we're now going to move over to PySpice, and we're going to try and implement this within our Python code. So we're back here on the Atom editor, And I'm just going to talk you through this code because I've got it all kind of pre-written, and I'm going to be talking you through it. So at the top, we have our top matter. We have the various packages imported, so numpy, matplotlib, sys, os, which we're going to be using to import some raw spice later. We've got the various PySpice packages. Notably, we've also got this spice library package module we're importing, and we'll discuss that more later. We then have our logger. And then finally, we have the thing that will toggle ngSpice to using the sub-process simulator if we're on Linux, whereas when we're on Windows, we'll use the default shared library. So that's all the top stuff. So let's get down to actually building the very basic circuit we had earlier. So we were creating a circuit. We're naming it tutorial 5.1. Then the first thing we're doing is we're adding a voltage source. We're going to be doing a DC sweep, so that voltage doesn't really matter. And then so we then on the output node of 2, we connect that to ground with this resistor. And we then want to connect between node 1 and node 2. We want to connect it with a diode. So what I'm calling here method 0 is not actually one of the methods, because we're just defining the diode locally. So we mentioned this, we discussed this in a previous episode. You can define various different models. For example, we can define a diode type and then we can assign all the various properties of the diode, and then we can just call that diode directly. However, we don't want to do this because we're not trying to define it locally. We're actually trying to import a circuit component, or a sub-circuit, I guess, in this case. So method 0 is what we're trying to avoid. So then there are 3 ways of doing this. The first of which, I will openly admit that I have not managed to get working. This is the method which is used in the in all the online stuff provided with PySpice. Unfortunately, if you look at the documentation, what seems to be used is this function called the spice library, which I mentioned we imported earlier. Now, as far as I can tell from reading the documentation, this is kind of how it should work. So what should happen is that we use this function spice library and we provide it with some path. What happens is this function then scans that path location, that directory, and looks for .lib files and then kind of imports them. And then what happens is you can call the various libraries using their names, and then it will return a directory which we can include. And then once we've included the .lib file directory, we can then produce our sub-circuit using that particular imported model. Now, I can't get this to work. I can't quite figure out how that functions. So if you know how that works, please comment below with the solution. Unfortunately, this spice library function doesn't seem to be working, or at least I don't quite understand how it does work. But this is how I think it should work. So we're going to move on from this. That's what's shown in the documentation online, and that's obviously not the method I would recommend because I can't get it to work. So we're going to leave that. So remember, we're trying to add in this sub-circuit diode component between our voltage source and our resistor right now to sort of complete our circuit. So the second method is using the circuit.include function provided by PySpice, but rather than using the spice library to kind of detect and store where all of the .lib files are, we can just provide the path manually. So I'm going to go here. You can see that my Python file is in this folder, and then locally I have a lib folder within it which contains the 1n4148.lib file. So we want to include this. So what we can do is we can say, well, our path is lib / and then the name of the file. So if we do circuit.include of the path, and it should be included, and then we can use it. So let's just quickly try running this. And you can see that, oh, hold on, I didn't save it. There you go. Got to make sure you do that. Sorry. So now if I run it, you can see that we have the name of the circuit, and then we have the dot include, and this is the full path all the way down to lib/1n418.4148.lib, which that then includes the component within that library, and then we can then use that component as a subcircuit. So I've called this subcircuit import diode. And then if we go to our simulation output, which I'm saving as a picture, then we can see that it's worked. So just to sort of fill that in, we've created the circuit, and then as you can see lower down, I'm printing the circuit, producing the simulator, I'm running a DC analysis with a sweep defined by this slice, and then I'm just plotting the outputs and saving a figure. So that's all that's happening after we've defined the circuit up here. Now, one of the problems you'll notice or is that when we include it like this, what this circuit dot include function is doing is it's adding on the full directory path of the current system. So I'm on Windows for Subsystem Linux, so it's /mount. Otherwise, you'd be going straight from the disk if you're on Windows or whatever. But yeah, and this is a problem because if the syntax of this path is not correct, then you're going to get errors. And this is a problem this is a problem that happened to me. Specifically, it happened to me because I work a lot on my OneDrive for Business, within my OneDrive for Business folder, and that folder name is defaulted to OneDrive space and then the name of the business. And if you have a space within your folder name, that will throw an error because the Spice does not understand it. The Spice net listing does not understand that. So your pathway has to be perfect or with the correct syntax. So I would actually, while this works, you can encounter problems, and depending on the system you're on or the file folder you're in or whatever. So I would avoid this method, although it does work. So method 2 works fine, but I think the best way is just to actually use the raw spice itself. So what you can do is, again, we can use the raw spice. So rather than using that function which writes out include and then adds in the file path, we can actually just do it ourselves. So we've got .include, and then we've got the lib /blah blah, and then we add in some raw spice. And if you remember, we do that by doing circuit.rawspice plus equals to add a line, then the string we want, so this new line, and then we have to make sure we add in that OS line set such that it starts a new line, and that makes sure the netlist is completely correct. And then we can use the subcircuit we've imported. So if we now run this, actually this is going to throw an error. So if we now run this, it's thrown an error. And the reason I know that is because if we look up here, the double backslash function creates a single backslash string, and the net listing syntax doesn't like that. It actually needs to be a /. So if we go back to this, now it will run. And you can see that it's actually searched within the local directory to find the part we're using. So this, to me, is a lot more flexible, a lot more compatible regardless of the folder you're in and the system you're on. So I'd stick to this method if I was you. And again, we're saving this output characteristic, and it's all working well. So those are the various different ways of making sure that you can import correctly using PySpice, making sure that your simulation runs properly. I hope that's been helpful. If there are any particular things that you want me to look at, please leave a comment below. I'll do my best. As I say, I'm just trying to produce this kind of foundational introduction to PySpice and its uses. It's a tool that I've been finding very useful recently, and I hope you've been enjoying this series so far. So thank you very much, and I'll see you in the next one.